I'm now going to work through the answers to the questions of test number 1 taken in the spring term of 2001. Question 1 says work out 7.6 plus 32.45 plus 360 minus 14.34. We're going to treat this as a number of linked sums. There's the first sum, the second, and the third sum. So in the first sum, I'm going to add 32.45 and 7.6. I'm going to put a 0 in that column because it helps me when I come to add up these two columns. 5 plus 0 is 5. 4 plus 6 is 10. I put down the 0 and I carry over the 1. 2 plus 7 is 9. Add in the 1 is 10. 0 down, carry over the 1. 3 plus the 1 I've carried over is 4. And I trace the decimal point into my answer, 40.05. That's the first sum. The second sum asks me now to add 360. 360 does not have a decimal point in there. I'm going to write one in, and the decimal point needs to appear straight after the units column in this number. And I'm going to finish it off by adding 2 zeros so that when I line up the second number, 40.05, I have the same number of digits in my decimal columns in both numbers. Now to add. 0 plus 5 is 5. 0 plus 0 is 0. 0 plus 0 again is 0. Then I have 6 plus 4 is 10. Put down the 0 and carry over the 1. 3, and I add in the 1 that I've carried over to give me 400.05. That's my second sum. The third sum I need to do is subtraction. 400.05 subtract 14.34. And as you can see, once again, I've made sure my decimal points line up. Therefore, I know all of those numbers are in the right value column. I start my subtraction. 5 subtract 4 is 1. I can't subtract 3 from 0, so I have to borrow. And because there is nothing to borrow until I get to my hundreds column, that's where I take 1 from. But I have to pass it along the number, giving it to the next column as I go. So I now have 10 in this column, from which I will take 1, pass it over to this column. I'll take another 1 from that column and I'll pass it over here, and this is where I need it. I now have 10 from which I can take 3, and that leaves me with 7. 9 take away 4 is 5. 9 take away 1 is 8. And 3 with nothing to take away is 3. Make sure again my decimal point goes in my answer in exactly the same place as it was in my sum. So the answer to that question, as you can see, is 385.71. Now for question 2. The setup I'm going to do is a Chinese grid method, and I lay my numbers out so that my first number goes along the top, and then around the corner goes my second number. I create a box underneath these numbers, which I split into equal sized boxes the same number of columns as I have numbers going across the top. I then split these boxes diagonally from the top right to the bottom left, and I begin a multiplication. 1 times 8 is 8. There are no tens in 8, so in the top half of the box is 0. In the bottom half of the box is 8. 8 times 8 is 64. 6 tens, 4 units. 7 times 8 is 56. 5 tens and 6 units. And the last multiplication is 4 times 8, which is 32. I'm now going to add up the diagonal columns I've created in my sum. And in this first diagonal, there's only ever one number, and in this instance it's 8. In the second diagonal column, I add the 0 and the 4 to give me a total of 4. The third column, 6 plus 6, gives me 12, so I write down the units and I carry over the tens as just a single value in that column, ready to add in. 5 plus 2 is 7, add in the 1 is 8. And in the last column, there is only one number, 3. To ensure my decimal point goes in the right place in the number, from the top, it just drops and it appears between the 2 and the 4. My answer is now wrapped around this box, and it is 382.48. Question 3 is a unit value question where it's telling me that a number of items, in this instance 6 tins of baked beans, cost £4.74. The first step to answering this question is finding out what the cost of 1 tin would be. And to do that, I need to divide the total cost by the 6 tins. How many 6's are there in 4? 4 is too small to be divided by 6, so that's 0. Now, because I haven't used any of this 4, I carry that over to the 7. How many 6's are there in 47? There are 7. 7 6's are 42, so counting up to 47, I've got 5 left over, which I carry over to the 4. This number now becomes 54. How many 6's are there in 54? There are 9. My decimal point in the question goes in exactly the same place in the answer. This was pounds, so this is pounds. But I also know that 0.79 pounds is 79 pence. So 1 tin of baked beans costs 79 pence. To work out the cost of 7 tins, I now need to multiply 79 by 7. And you can use any method you like, but I'm going to use this Chinese box method again. 9 times 7 is 63. 6 tens, 3 units. 7 times 7 is 49. 4 tens, 9 units. First column, 3. Second column, 6 plus 9 is 15. Carry the 1. Final column is 4 plus the carried over 1, and that's 5. 553 pence can be converted to pounds by dividing that number by 100 and inserting the decimal point between the two fives. So the answer is 7 tins of baked beans cost £5.59. The final question on that page is a total divided by a ratio. So in order to do this, I am first going to add up the parts of my ratio. 2 to 4 means I'm adding up 2 and 4. I have 6 parts to my ratio. To find a value for one part, I'm now going to divide my total amount by my total number of parts. 6's into 1 don't go, 1's not big enough. Carry over the 1. 6's into 13 go 2. 2 6's are 12, so I need to add 1 to make the 13. It's that 1 I carry over. 6's into 12 go 2. I've calculated that 1 share is worth 22. So I've done my addition, I've done my division. Now I need to do my multiplication. Which is going back to my original ratio of 2 and 4 and multiplying each one of those by the value of 1 share. 2 shares at 22 gives me a value of 44, and 4 shares at 22 is a value of 88. My answer for this question is 44 and 88. These next few questions are referring to a table of temperatures in 5 cities. We're comparing the midnight temperature with the midday temperature. Now the first question says, which city had the lowest midnight temperature? And when we think of these numbers on a number line, we know that what we're looking for as we come away from the 0 is the greatest number. So if this was 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, the furthest number away from the 0 going towards the left is the coldest temperature. The question is asking for which city is that, and the city is Edinburgh. My second question is looking for the difference in temperature between Cambridge's midnight temperature and the midnight temperature in Leeds. So I'm going to draw a number line again. I'm going to indicate on this number line the lowest temperature, which is the temperature in Leeds, -6. On the other end of my number line is the warmer temperature, which is Cambridge at -1. Now I need to count how many jumps it's going to take me to get from -6 to -1. One, 2, 3, 4, 5 jumps, therefore 5 degrees. The difference in temperature is 5 degrees. I'm going to do one last number line for this question here, which says which city has the greatest rise in temperature from midnight to midday. I'm going to put on the bottom of this number line the lowest temperature, which is -7, and I'm going to go right up to the highest temperature, which is a +6 degrees. I'm now going to cut this number line into equal pieces and number it. And now I'm going to actually count the difference between each of these temperatures and compare them. So first of all, Belfast, going from -3 to a +4. 1, 2, 3, 4, 5, 6. That's a difference of 7 degrees. Cambridge goes from -1 up to 4. 1, 2, 3, 4, 5. A difference there of 5 degrees. Edinburgh, -7 up to -1. 1, 2, 3, 4, 5, 6. So far, the biggest difference is Belfast. Leeds goes from -6 to +3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Putting Leeds into the lead. Checking out London, -2 up to a +6. 1, 2, 3, 4, 5, 6, 7, 8. Still not quite as big as the difference in the Leeds temperatures. Therefore, the answer to the question, which city has the greatest rise in temperature? It's Leeds. Just at the bottom of this page, you can see question 6a, which is asking us to multiply -4 by -8. And as we've learned, we're first of all going to multiply those two numbers together. 4 times 8 gives us 32. We're now going to consider the fact that we're multiplying two negative numbers, and a negative number multiplied by a negative number gives us a positive answer. So -4 multiplied by -8 gives us positive 32. Now we're on to question 7, and it's a simplification question. It's asking us to simplify 3x plus 4x minus 2x. We're going to do it in two stages. 3x plus 4x gives 7x. 7x minus 2x is 5x. So there, in total, we have 5x. The next question is asking us to simplify also, but it's a multiplication. And it's the number that multiplies with the number. So 4 times 3 gives us 12. And that 3 is a 3x, so that answer is 12x. The next one has G's and H's, which we're going to put together. So we're going to do this in two parts. First of all, our G's, putting a circle round those. It's asking us to start off with 8G and subtract 3g. 8g subtract 3g leaves us with 5g. Putting a different shape round my h's means I can clearly see I've got 6h from which I need to add another h. 6 plus 1 is 7. 7h. Now question 10 simplified. We're going to deal with the numbers and the letters separately. So 2 times 2 gives us 4. The letters p times p gives us p squared. Putting these two terms back together again, the answer to 10 is 4p squared. Don't forget the 4. Our final two questions on this page are substitution questions. So I am going to rewrite my formulas substituting the letters for the numbers. So in the first formula, where Q is equal to 2 lots of C plus D, I'm going to take out the C and replace it with the value I'm given, which is 3. So 2 times 3. I'm then going to add the value I've been given for D, which is 2. And looking at this sum, I know, because of my order of operation, I've got to multiply 2 by 3 first, and that gives me 2 by 3, and that gives me 6. Adding in the 2 gives me a final answer of 8. Question 12 is slightly more complicated by the fact that we're given a negative number to substitute. But we're actually going to do the whole thing in the same way. 3p plus 4q, where p has a value of 5. That's 3 times 5. To it, I'm going to add 4q, where q has a value of minus 2. So first of all, I've got a positive calculation. 3 times 5 is 15. Now I have a negative calculation. Plus 4 multiplied by negative 2. Deal with the numbers first. 4 times 2 is 8. A positive number multiplied by a negative number gives me a negative answer. 15 and take away 8 overall gives me a final answer of 7. We're doing well, folks. We're just now going to do the last few questions on this page, and they're all about probability. So the first one we're going to tackle is a probability tree diagram. And you can see the probabilities are detailed in decimals, so we're going to follow that lead, and we're going to put in the missing probabilities in decimals. So if with regard to game A, a lose has a probability of 0.8, the win is going to be 0.2, because 0.2 plus 0.8 will give us a total of 1. Probability is always out of 1, remember. So when we look at game B, we're looking for the losing probability, and if the winning probability is 0.3, the losing probability is 0.7. because 0.3 plus 0.7 again gives us an overall probability of 1. This bottom set of branches is always a replica of these top branches. So the winning game B has a probability of 0.3 and the losing of game B has a probability of 0.7. There is the tree completed. Now, to work out the probability of winning both games, we remember when going left to right through our probability tree, we always multiply. And if we want to win both games, we're going to go on a journey that starts right at the beginning of our diagram. We're going to follow the winning branch for game A, which takes us right past 0.2. We're standing here looking at the next two branches of our tree. And again, we are wanting to win both games. So we're going to take the upper path again, going past this winning probability of 0.3. And as I said, when we're going through the probability tree, we multiply. 0.2 multiplied by 0.3 is 0.06. The final probability question here is a table of probabilities with regard to Mark taking a counter at random from a bag. There are blue, red, green and yellow counters in the bag, and we've been given the probabilities for 3 of those counters. We know that all of these probabilities would add up to make 1, so we can work out the missing probability by adding up the probabilities we do have, which gives us a total of 0.6, and then subtracting that 0.6 from 1. That will give us the missing probability. Green has a probability of coming out of the bag at 0.4. And with the last part of the question, if we are conducting an experiment, which Laura is doing here, she's taking a counter from the bag 50 times, we need to find the probability for the red counter coming out, 0.2, and multiply that by the number of times the experiment has taken place, and that's 50. 0.2 multiplied by 50 means we estimate that the red counter will come out of that bag 10 times.